Hey everyone, and welcome to this Terraform training. I've been using Terraform a lot, and I've been using it for many years now, so I hope I'm in good position to share some of that knowledge with you today. As always, remember that you can learn Terraform and a million other DevOps and cloud-related topics on our official Automation Avenue platform, but you probably already know that. If you don't, just search for automationavenue.com to become a member of our DevOps community there. And if you have no idea what Terraform is, that's a perfect place to start your journey. And by the end of this training, you will have all knowledge required to work with Terraform. Terraform is the most popular infrastructure as a code tool, and it's mainly used by DevOps and cloud administrators to create and maintain infrastructure in the cloud, but it doesn't mean it's just for cloud though. You can use Terraform in your home lab, for your Proxmox server, and in many different places as well actually. And I use it nearly every day, so I can tell you that it's a really neat and very convenient tool as well. So I hope you will like it too. Maybe let's start with what Terraform actually is, how it can help us, and what problems it resolves. As I said, Terraform is an infrastructure as a code tool. That means we can create and maintain our infrastructure in the form of a code. This means I can write a piece of a code, and that code will create a bit of the infrastructure for me. That bit of infrastructure can be, for example, a single server in AWS Cloud. It can be maybe one virtual server on my Proxmox. It can be maybe a cloud load balancer, or it can be also a complex code that will create entire production infrastructure that might include hundreds of servers. So regardless what I want to build, I still can use Terraform for all of those purposes. And Terraform has a very wide range of applications. It's most commonly used in cloud solutions such as AWS, GPC, Azure, DigitalOcean and others, but it can work with nearly anything you can imagine. If you check, let me open the browser maybe, and let's search for Terraform providers. I will pick that first link at the very top, Browse Providers, and you will see here endless numbers of so-called providers. You can see AWS, Kubernetes, Azure, Google Cloud Platform. They are at the very top because these are the most popular places where you would work with Terraform. But if you scroll down, have a look. This is just the very first page. Check those partner providers. This is just the letter A. Have a look. We've got 95 pages of partner providers. So now let's say I want to work with Proxmox maybe, yes? We've got Alibaba Cloud Stack, I didn't even know something like that exists. Never mind, Proxmox, yes? Maybe I want to work with Proxmox. I can search here for Proxmox, and you will see there is not one, but we can see all providers. So loads and loads of providers just for Proxmox. Any of these providers will let me work with my Proxmox server. But let me go back. What are those providers at all? So this provider is like a bridge that lets me use Terraform with that specific product. For example, if I want Terraform to work with AWS, I will need to include this AWS provider in my code. And then Terraform will download all necessary tools, will do some magic in the background, will install all it needs to work with AWS Cloud. And in this course, we will use Terraform to deploy infrastructure in AWS Cloud. But it doesn't mean this course is somehow AWS specific. This is Terraform course, not AWS course, and at the end of this training you will be able to work with all those providers, because we are going to learn Terraform concepts that can be applied to any provider you want to work with. So don't think that you will need another Terraform training if you want to work with, for example, Azure or GCP or whatever. The fact that we are going to work with AWS today is meaningless, because the same rules apply to any providers you want. You simply will be able to work with all of them. I only chose AWS because AWS is the most popular cloud provider and Terraform is the most popular infrastructure as a code tool. So I think it's a perfect combo. But now, what does it actually mean to program the infrastructure or to have infrastructure as a code? It simply means that instead of manually clicking on some icons in the AWS console to build something in the cloud, we can do it all in Terraform and keep it in the form of a code. Because Terraform is like a programming language. You can write that program, that code, in Terraform using a programming language called HCL, HashiCorp Configuration Language. And once you have that program completed, you can run it and it will deploy all the resources for you. And someone might ask, Marek, but I can build that infrastructure manually, yes? I can build it directly, for example, in AWS by clicking on some icons there and filling in the fields required. So why I should even learn about something like Terraform? Creating infrastructure manually in the cloud is indeed possible, however it has many drawbacks. The biggest problem with such manual approach is that when someone creates this infrastructure manually, for example I will create a server, and the next day someone completely different will start tinkering with this server and will start making changes to it. And now the problem is that we don't know who changed it and what has been changed, because we don't have the ability to track all those changes. For example, let's say I created that server in the cloud with a 500 gig disk. A bit later, there was an issue with disk space and someone increased it to 700 gig. The problem now is that if something happens to that server and I have to rebuild it based on maybe, I don't know, some personal nodes, then I will rebuild it again with 500 gig disk, because I might not even know about the fact that somebody increased that disk space to 700 gig in the meantime. So we have no trace of who, where, and what was modified. And it would be quite difficult to keep all such information in one place by just using some nodes. However, if we have that infrastructure in a form of a program, then we can program or hard code that information, so then everybody will know that disk on this particular server should have 700 gig. And if they have to increase it even further, they will change that value in that code. And they will share that piece of code with entire team, so everybody will be aware of that. And if I ever need to rebuild that server, I will not click any buttons in AWS. I will deploy that server using Terraform, using the same file in which those 700 or whatever current size is supposed to be. This size is programmed, is hard-coded in my Terraform code. So I don't even have to think about what disk, what instance type, what IP address to assign, and so on, because I already have everything clearly presented in the form of a code, and I can upload that code to remote repository like GitLab or GitHub, so my team can pull that code from that remote repository anytime they want to work with that server, or if they want to make any changes to it. But this is just one example. In reality, keeping all our infrastructure in the form of a program has many more advantages. For example, it will be very easy for us to create, let's say, 2 copies of exactly the same infrastructure. If I need one for testing purposes and one for production environment, I can just run that entire code in, let's say, completely different AWS account. And the infrastructure created will look exactly the same in both accounts. But I'm just talking and talking, but it will be much easier to understand when we see everything directly in Terraform, so let's just get started. To work with Terraform, we need to install it first, yes? So I will show you how to install it on MacOS, Linux and Windows machines. Let's start with Linux maybe, because on both Linux and MacOS the installation is trivial really, and the process for both is very similar. So in my Linux, let me minimize. So in my Linux, this is Ubuntu. Let me open the terminal and I will first type terraform -- version. And as you can see, the output says command terraform not found, but can be installed with sudo snap install terraform. And that's true, you can just run that command and the job done. But I'm not the biggest fan of snap packages though, so let me show you another way you can do that. Let's open the browser again, and I will search for terraform.io. So that's terraform.io, and I will click that download button. And you will see not only macOS, Windows and Linux, but also FreeBSD, OpenBSD, Solaris, etc. But I'm interested in Linux now, and you've got, because every Linux can have different package managers, you have to choose your version of Linux, whatever your distribution is, yes? For example, for me, it's Ubuntu Debian. I can just click that little icon here, it will copy everything for me. That's now copied, all those commands. So let me go back to terminal, and I just paste it. That's it. Now click enter. Now here you might wait for a while, some stuff has to be downloaded in the background, so that will depend on your internet speed. Okay, now it asks for sudo password, so let me provide it. And now it will finish the process. That's done, which means if I use up arrow, and run this command again, terraform -- version, now I should have, well, let's see, that's what I was looking for. Now it shows me the version of Terraform, which means Terraform is successfully installed. But in fact, if we go back there to this Terraform IO, we can also use the macOS version. If we go to Operation Systems macOS, we can see we can install Terraform using Brew package manager. And in fact, if I go to Linux even, you can see Homebrew is here as well. If I click that, it's basically I get the same information. If I go to Linux Homebrew, or if I choose macOS operating system. So again, I can copy that. I can now, let me open my Mac terminal. This is different machine. This is my Mac, but I should be able to just paste it here. Yes, I am. I just click enter and wait. It might take a while as well. It's doing something in the background. Okay, auto updating Homebrew. Now it downloads whatever it needs to download. And now it should be completed. So if I run here, maybe let me clear that. If I run Terraform version, I will also have Terraform version. That means Terraform is installed correctly. For Windows though, it's a little bit different story, and I would have to jump on another virtual machine where I have Windows installed, so let me do that. Okay, now I'm on my Windows machine, so I will open Firefox and type terraform.io in Google search. I will go to Downloads and then to Windows tab. And within that Windows tab, I want the 64 version of this program downloaded. So I just click this. Starts downloading, and now if I show in folder, we can see it's zipped file. It's compressed file. So I can right click on it and I say extract all to uncompress them. Click extract, and now if we go back to downloads, you can see the compressed version and uncompressed version. So if I open this, I can see one file. It's called Terraform. And it's not the installer, it's .exe file, which means there is nothing to install. Clicking this file will execute, means I will simply run Terraform by clicking this file. If I click View and File Name Extensions, you can see it's terraform.exe, executable file. Yes. But to work easily with that file from the command line interface, I suggest we do one more thing. Let's first copy this file somewhere on this C. Let me copy it. I can now close. Let's close everything. I will go to C, and you might want to paste it somewhere in program files, but to clearly show you what we are doing here, maybe I will just create new folder right here. I will create new folder and I will call it Terraform maybe. And in that Terraform, I will have that file, terraform.exe. So my path to this file is c/terraform/terraform.exe. And now, once we have that file in this location, we call it path, yes? It's c/terraform/terraform.exe. That c terraform is our path to this file. Maybe let me copy this path, c terraform. I will just copy that. I will minimize this window, and I will search for environment variables. We can see best match, edit the system environment variables in control panel. That's what I need. That's it. And now I click that environment variables. Here I need that path variable and I click edit. And we can see we already have one, but I want to add another one. I say new. And I will just paste what I copied, which was that c:\terraform. And I say OK. So I can click OK here and OK there, because that's all I want to add. That means now, if I open a terminal, maybe I will open PowerShell. So Windows PowerShell, and if I run Terraform -- version, I can see I have Terraform installed because it shows me the version of that Terraform, and that's because our Windows system knows where to find the file, the terraform.exe file, because we just added it to the path environment. And that's all it is for Windows. You can start working with Terraform on Windows from now on. We have Terraform now installed and we are ready to start creating the infrastructure as a code. But where we can create that infrastructure? And as I previously mentioned, we are going to create that infrastructure in AWS Cloud, but any resource or any location that has Terraform provider will work for us. I will focus on AWS Cloud because it's the most popular cloud provider in the world, so it makes perfect sense to work with that cloud. If you want to follow and practice all steps shown in this training though, that means you need to set up your own AWS account and start deploying your infrastructure there. So in the next few sections, we will do exactly that. We will go through AWS account process creation and configuration, and we will see how we can connect our local Terraform to that remote AWS cloud, to that AWS account that we are going to create. If you already have an AWS account, or maybe you want to use Terraform with completely different provider, then you might want to skip some of the initial videos here where we create that AWS account and start from the one where we set up AWS users and groups, because that should give you a clear idea on how you can use that information with whatever your chosen provider is. I hope that makes sense. So let's start creating and preparing our AWS account then. This is new, fresh operating system with absolutely nothing configured, and we'll be creating here new AWS account. So let me open the browser, and we'll navigate to something like AWS Free Tier. And what actually Free Tier is, we'll talk about it later. But now let me just explain shortly. It's simply an AWS offering that lets you using loads and loads of resources for a year for free. When you create new account, you can use those services for free for 1 year. But we'll talk about it later when we actually create resources. Now we're creating the account itself. So as you can see here, I have create an AWS account. So let's click that because that's what we are interested in, yeah? Clicking this, it takes me to that web page with that create a free account button. So let's click on that. And maybe let's accept those cookies. And now what I need is some kind of email address. So it can be any email address you use or you own. You just have to be sure you can access actually that email during the sign up process, yes? I will just use gmail.com. This is important bit. The one below, it's just an alias for your account. It can be anything you want it to be called. Automation Avenue, but it's not that important really. The email is important here. I click verify email address, and now I will have to just wait for the email to arrive. Oh, as you could probably hear, the email has just arrived, and I've received a verification code. So I have to type it here and click verify. Okay, now I have to create the password for root user. We'll talk about it a little bit later, who is actually root user, but now let's just create a password. And as you can see, it has to include uppercase, lowercase, number, and non-alphanumeric character. Just make sure you've got that all. Even when I just start typing, let's say capital letter, as you can see, first box is ticked, lower letter, now digit, and now non-alphanumeric. As you can see, all those boxes are ticked. My password is good enough for them. Now I have to repeat it. And that's it. We can continue. Just wanted to note, here on the left, you have a link if you want to explore those free tier products. So this is the link you can use. But never mind, at this stage we'll just concentrate on the sign-up process. So I'll just click continue. I will save the password. And now it asks me for contact information. It asks me if it's business account or personal account. I will treat it as personal account. Anyway, if it's business, it will ask you for organization name as well. Let's click personal. And my name is... You have to give them name and address, yes, and the phone number. And you agree that you've read the customer agreement. So we can go further to step 2. Now it asks you for billing information. That's where you have to provide your credit or debit card number, because, as I said, there are some free services you can use, but you can actually, by signing up, you can use all services, the ones that are free and the ones that you have to pay for. That's why you have to put the credit card details, but in later videos I will show you how to create budget. This budget will inform you if you actually started using some services that you have to pay for. But for the time being, we have to put that information in to be able to progress. That's the credit card, and we can go further. As I used my Revolut card, I have to confirm that in the banking application. I click confirm, and that authorizes this step. Now it asks me for a telephone number to use to confirm the identity, and I will use the same that I used previously on previous page. Now the captcha. Hope I have it right. If it's completely messy, you can also always refresh it. It will generate new one, because some of them are generated in such a weird way that you can barely see what's there. Okay, now let's wait for the verification code sent to my phone number. And as you could hear, it's just arrived. And we can continue to step number 4. Here it asks me again what type of account I really need. So we'll go obviously with the free one. I don't want to pay $29 a month or $100. The free one is more than we need really. And that's it. We click complete, sign up. As you can see, it was quick and easy process. And it says we are... Oh, okay, as you could hear, AWS says we're activating your account, but I believe it's just been activated. So yes, received the email, it said that I can start using my account. So I can click either this button or that button, doesn't really matter. Let's maybe click this one. Go to AWS Management Console. And now it asks me if I want to sign in as a root user or the IAM user. We really only have root at this stage, but I will show you later on in next videos how to create IAM user as well. So for the time being, as there is no choice, we only have root user, we'll put the email address we used for the sign-up process. For me it was gmail.com. We'll click next. And the password, the one that you just created as well for this user. And sign in. Not bad, is it? We are already in our AWS console. That's what it's called, AWS console, where we can do everything regarding this account or our resources. First thing I want to show you it's here. That says Automation Avenue. Remember, that's the alias we actually pasted during the sign-up process. So instead of some long weird digits, it will be Automation Avenue will be used here. For you, it can be anything you want to name this account as. The next thing is, we can see Stockholm. Well, weirdly chosen, I don't know why, but that's what we call AWS region. This is where you want to create your resources. So as you can see, you can create it all over the world. Let me just change it to London, because that's the closest for me. But we'll talk about it later on as well, so don't worry about it now. What I want you to do is to activate multi-factor authentication for the root user. That's very important. This account has to be very secure. What you can do, here in this search field, you can put IAM. We'll click that, and you can see that even the Amazon itself, there is a security recommendation 1, add MFA for root user. To be honest, every single user you create should have MFA enabled, in my opinion, but root one is definitely one you need to create MFA authentication for. We can add MFA here, clicking this button. And now we have a choice, what we want to use as a second separate authentication method. The easiest way, I think, is Authenticator app, which is chosen by default anyways. You can call, for example, for me it will be my Samsung phone. I can use that as an that doesn't really matter, it's just for you, information for you, where this authentication will arrive. And we can choose Authentication app, click next, and now you can see you will have to install one of the applications on your phone, either Google Authenticator, Duo Mobile, or some other apps that the list of all applications you can see here. But basically, you need just one of them. Google is a really good one. I can recommend that one. And then, once you've installed that application, you have to click that Show QR code and just scan it with your phone. Once you scan it, you will receive MFA code, which you will have to paste here twice. I mean, first code and second code. And this way, you will add that device as authorized one to receive the MFA codes. I will not do that because this is just temporary account. I will remove it later on, but you definitely should do that. In next video, I will show you how to create that budget before you start actually creating any resources in AWS Cloud. But you've got your own AWS account now, so congratulations. In previous video, we created our new AWS account, we created and logged on as a root user, and we added MFA authentication for that root user. What is next most important thing is that we should know how much money AWS services will cost us if any. So we can either try to not spend any money there, just using free tier eligible services, but maybe we are okay to spend some money, but we don't want to exceed certain threshold, like maybe $10 a month, let's say. But one way or another, we definitely want to be in control of our budget. And that's what AWS Budget service exactly is for. Being logged on to our console, still as a root user, we can type here in the services, we can search for budget. And we can see here budgets as of billing and cost management feature, or we can simply click that billing and cost management service, which budget is part of. So maybe let's click the top one. Doesn't really matter. Here you usually see some summary, how much last month it cost you, what's prediction for this month, but because this is new account, there is no data available yet. But doesn't really matter, because what we need is budgets here in the left down corner. Let's click that budget. And as you can see, we can create a new budget here by clicking this button. Now we have a choice of using a template, or we can customize, so using advanced settings. Let's stick to just simplified version. And now, what type of template do we want to use? By default, you can see zero spent budget. Create a budget that notifies you once your spending exceeds 1 cent, which is above the AWS Free Tier limit. And that sounds good, doesn't it? Because that means if I spend any money on anything, I will get a notification. Also, that's important to remember, the AWS budget will not disable any resources for us. It's not meant to be. It will only notify us every time we exceed certain threshold we configure here. The first threshold will be that 1 cent. If we use any service that we have to pay for, it will send an email to the email address we specify here below. So maybe before we go there is a budget name as well. It's called My Zero Spend Budget, which is okay, but let me just personalize it. Maybe Marek Zero Spend Budget. Doesn't really matter, it's just a name. And here is where we enter the email address. And as you can see, it doesn't have to be one. You can put multiple email addresses here. You just have to separate them using commas. I will just use one. Let's say Marek@Avenue. That's it. If I wanted another one, I just use comma and blah blah blah. Yeah, but we'll just use this one. And that's it really, I believe, because yes, we can leave everything else as it is. And you can see a confirmation. You will be notified via email when any spend above 1 cent is incurred. That's fine, that's what I want. So we create a budget. And that's it. We've got our budget, and don't ask me why it always shows $1 rather than 1 cent. I don't know why it is like that, but it should be for 1 cent. But that's not a big deal, it works as expected actually. But maybe we want to create another budget. What if we want to sometimes use some services, but we don't want to exceed $10 a month? So we can create just another budget and set threshold to that. So let's click Create Budget. We'll leave it as a template, simplified, which is much easier. And now we will change from zero spend budget to maybe this one, monthly cost budget. What's interesting about it, as you can see, it notifies you if you exceed or are forecasted to exceed the budget amount. If you start a new month and on the first day you exceeded $1, this AWS budget can see you will actually exceed $10 by the end of the month. So it will send you notification before you actually reach that $10 threshold, because it's forecasted for you to exceed that by the end of the month. I hope that makes sense. Because our ultimate goal is not to exceed $10 a month. That's exactly what we need. So now we can scroll down. Let's call it $10 budget, yeah? So it's clear for us what it is about. Now we just adjust this value to $10. And again, just list of emails we want that notification to be sent to. And that's it. And here below, you've got a summary of how it works. You will be notified when your spend reaches 85%. So if you are at 850, let's say, you will get email. Then it will be at 100% at $10. But the third option, if your forecasted spend is expected to reach 100%. But that's very handy and useful for us. That's exactly what I need. Just create a budget. And this way you can create as many budgets as you want and get notified every time you reach any of those thresholds. In previous video, we created AWS Budget. We can monitor our spending using those budgets, etc. But what I wanted to notice is we are still logged on as a root user. And that root user is not really the one we want to use to create anything like resource-wise, like servers, load balancers, etc. We don't really want to use a root user for that. What we should use instead is some type of admin account, admin user, or any other user that, has some limited scope. So in this video, we will create admin IAM user. So the service I need is called IAM. We already saw that when we created MFA authentication, when we were creating the account itself. As you can see, I haven't completed that step, but I hope you did. But what we want now, though, is a new user. If we work for an organization, we don't usually create one. We create many, and we put them in some kind of groups of users. So maybe let's start from groups instead. That's usually the way. But it doesn't really matter. We can start from any point, and we'll end up in the same place. But let's start from group. So we create group. So we can create a group of users, and we will call them admins. It will be a group of admins. And every single admin should have similar set of permissions. And those permissions are configured here. And you can see at the very top, administrator access. That's exactly what we need. We tick that, and we can see provides full access to AWS services. And that's fine. We need them to access services, but they will have limited access to view any financial information. So we call them admins, and we create group of admins. So that's now done, but we can see we have no users within that group. So now we can go to users, and we will create a user and place it within that group of admins. So let's just click create user. Let's call it admin, maybe administrator. So slightly different name. And now what we need, we have to tick that provide user access to AWS Management Console. And you can see it's optional. And somebody might think, isn't that the whole idea why we create that user? We want access the AWS console. That's where we are right now, yes? Well, yes, that's true. But every user can have console access or what we call programmatic access. And I will show you in next video what's the difference and how to configure that. But for the time being, we need to access the console, or admin user should be able to access the console, just as we do right now. So we tick that, provide user access, and then we click I want to create IAM user. Here we can have auto-generated password, or we can have custom password. Custom, I will be able to type it in. Okay, and now users must create a new password at next sign in. Recommended. This is handy if you create that account for somebody else. So you created user, let's say, I don't know, Jack. You gave him a password, and then you click that. So when he logs on, he will have to change it on the first login. But because we create this account for ourselves, I would say let's untick it. And we will be able to use just the password we typed in here. And that's it. We can click the next button. Save, maybe no. And now at this stage, we can add the user to the user group we created 2 minutes ago, as you can see. So let's add him. Next, as you can see, if we didn't have group created yet, we can create one here as well. But because we already have group of admins, we can just go straight to next. And that's it. Here is a little summary. Username is administrator. He or she will have permissions from admin groups. And it will be custom password, and it doesn't require the reset on the first login. That's cool. Let's create that user then. And now we have those sign-in instructions. We can copy that information, or we can download everything as a CSV file. And I will use this option. As you can see, administrator credentials CSV file showed in my downloads. I can use that, but what I really need is that URL. It's pretty handy. Let's copy it, maybe. I still have it in that file as well, but maybe let's copy it here. And now I will log out from here. I'm still logged on as a root user, remember. So we sign out. We can either log back in here, but this time as an IAM user, and we will need account ID, 12 digits. But remember, I copied that URL. Let me open another tab. Maybe I will show you both ways. I can paste it here. Remember that long URL I just copied? This actually already has that account ID. So one less thing to type. I click enter, As you can see, the only difference is I'm already on page where I can log in as IAM user. I don't have to choose that. And I also have account ID already placed for me. So now I just want to add administrator, which is the name of the user we just created, and the password we created for that user. And now I can sign in. But maybe before I do that, let me just go back to this tab. And as you can see, it's a bit different login page, but it works exactly the same. So the account ID, I can actually copy from here. Might be easiest way. Let's go back. I can paste it here. And here, if I click next, as you can see, we are exactly in the same place. Hope that makes sense. So because I already have that all filled in, let me just sign in from here. And close this one. Okay, we are now logged in as an IAM user. As you can see, it says administrator at that long account number, finishing with 8888. And you can also see one more difference, because you can see access denied in cost and usage. As I said, IAM user will have limited visibility to financial information. And that's fine. We will create this user to create services. They don't have to do anything with the finances. So I hope that helps. In previous video, we created the IAM user, and we are now logged in as an IAM user. It's called administrator, and this is our account number. But remember when it asked if we need console access? This is the AWS console, and it asked us if we want to access it at all. This at first sight might look ridiculous, because somebody would say, of course we want access to that, yes? But not every user will need this access, because AWS also has a programmatic access, and everything we can do here, we can also do programmatically from some remote location. And instead of trying to explain that, let me just show you. Simply, that's the easiest way. So let's go back to our IAM console. IAM, not IAM. Let's go to that IAM where we created our user. And as I said, it's also recommended to add MFA for the IAM users, not only for root user. But let me concentrate on something else, because what I wanted to show you is if we go to those users, maybe I will click here, doesn't really matter where, if here or there. So this is our user, it's called administrator. Let's click on that. And what we need now is security credentials. Let's click security credentials and then scroll down. And here what we're interested in is access keys. These are those programmatic access keys I was talking about. So let's click Create Access Key. We've got quite a choice, but we want really the first one, command line interface, because that's where I will want to connect to my AWS account from remote server or laptop or whatever. So that's it. I just need to confirm that I understand the recommendations. I click Next. Here you can describe it, but I will just click Create Access Key. And as you can see, we've got access key and secret access key. So this is equivalent of username, and this is equivalent of password. So from remote location, I will be able to log in to this account as administrator using this kind of username, which is called access key, and this password, which is called secret access key. And it's an important moment, because this secret access key will be shown only once. Let me show you what it looks like. I will remove it later on. It's very important that you do not show this to anybody. As I said, this is equivalent to your username and password, so if anybody can see that, they will be able to log on to your AWS account using those credentials. So be careful with that. I will remove them before this video is published. But what we can also do here is download the CSV file. I will click that. This will be, as you can see, administrator credentials. No, sorry, that was for previous video. Administrator access keys is the one that we are downloading now. So we will have that information in that file. So that's it. Let me minimize that and let me open the terminal. So this is my laptop, yes? I'm at home. It can be your PC, your laptop, or some other server somewhere. How can I now access that AWS account from here? So what I need is AWS CLI, it's called. Okay, we need AWS CLI, but if you type, for example, AWS version There's a very slim chance you already have AWS CLI installed. We usually have to install it first and configure it. So let's do it now. Let me just go back to our browser and let's Google how to install AWS CLI. And now I am on Ubuntu, but you might Google for any operating system you're on. So let's check that first link. Let's scroll down. Here we've got the instructions. So if you're on Windows, you would use this. For macOS that, but I'm on Linux as I said. And well, it's not even normal Linux, it's ARM version. So I have to switch here as well to ARM version of Linux. And what I really need is to just copy those commands. So I can click those two squares. It's now copied. And go back to my terminal and just paste it. Enter. And that's it. So now, maybe let's clear it. So now, if I type again AWS version, as you can see, now I've got it available. Okay, so how to configure it now? They fortunately didn't make it complicated. It's command AWS configure. Click enter, and now it asks you for that access key. This is the one, you remember? This is your access key. You can copy it here. Let's go back, we paste it, enter. Now, secret access key. We have that as well. We copy this is equivalent of your password. Let's go back, paste it here. What now it asks you for is default region name. I know we didn't talk about regions yet, but region basically is where you want to create your resources usually. Depending on where you are, you will choose your region. For me, it's a London, so it's EU West 2. It's not really something you have to type in, you can leave it blank, but then you will have to specify every single time you create something, you have to specify which region this resource has to be created. So for me, because most of my resources will be in EU West 2, sorry, did I say 1 or 2? It's EU West 2, but yeah, because EU West 1 is Ireland. So I want everything in London, yes? So it's EU West 2. But this is something you will be able to override later on anyways. So it's just for your convenience, but you can leave it blank as I said. If you have default one, you will not have to type it, but you will be able to override it. Okay, so enter, and output format, well, not bothered right now. Now, I should be able to access my AWS account from here. So maybe let's start with AWS Help. It will show you all of the services we can access using that command line. And as you can see, there is basically everything you can access in console. You can also access it via that CLI. And because we don't have any resources, might be tricky, but we can use that IAM, because we've got user created. So AWS IAM, and then maybe help again. See what possible commands we have for AWS IAM. This one looks okay. List users. Okay. List users. See what we've got here. Alright, little hiccup, because this is new system. As I said, there is nothing installed here. It says no such file or directory less. Well, my guess is because we have to install less. Okay. Sudo apt install less. Okay, a little hiccup, let's try it again. And as you can see, now it works. It knows we've got user administrator, it gives us the user ID, and some more information like when it was created or when password was last used. So this way we can access our AWS from our laptop using command line interface. Okay, so here I am in my AWS console. I'm still logged on as IAM user administrator, and the service I need is called EC2. And you can see services EC2 virtual servers in the cloud. That's exactly what we need. So I clicked on it, and as you can see, instances running 0, because I don't have any virtual servers yet. So let's create one. To create one, we can click on that orange Launch Instance button. I'll click that. And now we can specify all the details for our server. First is name, and name is really not important, but let's name it Mark's server. Doesn't really matter what you name it, it's just, it's just so you recognize it's yours. And we scroll down and we can see operating systems that are available for our server. Amazon Linux is picked by default, and Amazon Linux is like a Linux Fedora based system with a lot of tweaks from Amazon, and that's cool. But we can also have macOS, we can have Ubuntu, Windows. They're all called Amazon Machine Images. If you click this button, you will see there is thousands and thousands more of them. But let's just stick to the basics maybe. I will just pick Ubuntu. What's important about Ubuntu or Amazon Linux, you can see it's free tier eligible, and I will talk about it in a minute. But for now, maybe I will switch to Ubuntu, which is also free tier eligible. But that's fine for now, we'll get back to it. So I scroll down, here I can choose architecture of my processor. It's x86, it's usually Intel or AMD, or ARM is usually, like AWS has their own processors, they are called Gravitons, so you can use that if you want. But I will just stick to the x86. And here you can choose the type of your server. So we've got T2 Micro. As we can see, T2 Micro, well, let me just maybe open this. You can see there is many and many of them available. You can scroll down, like, as you can see, loads and loads of them. But what's important about this one is that it has also that free tier eligible kind of a label, yes? Let's call it. You can see this server has one virtual CPU and 1 gig of memory. And below are the prices, how much it costs to run it. But I want to discuss one more thing because we go back to it, to that free tier, I mean. So let's scroll down for now, and we've got Keeper. Keeper is SSH key that we can use to connect later to our server from remote location. Like from this laptop, from my laptop, let's say, if I wanted to connect to my server, I will need a keeper. And as you can see, I don't have a keeper, and it says I can proceed without a keeper, but it's not recommended. That's not really what I want. I want to create a new keeper. So I'll click on that button. And I can call this keeper whatever, Mark's key maybe. And you know what, maybe here we'll change to that ED255 blah blah blah, because this is the newer and better version of that key. But both of them will work fine. And now we'll just click Create Keeper. So as you can see, it also downloaded automatically. I will see it in my downloads, the marx_key.pem. That's the key I will need to later connect to this server. As you can see, it's now picked, Keeper Marx key. So happy with that. Now we've got network settings. And I don't really want to discuss network settings now, because this is like a very broad topic. But if we leave everything as it is, this server will work exactly as I want it to work anyways. So we just want to be sure that auto-assign public IP is enabled, and that create security group has this allow SSH traffic from anywhere. This way we will be able to connect to our server. If those both are exactly like here, that's all I really need. So we can scroll further. So we've got configured storage. This is the hard drive for our server. And as you can see, by default, it has 8 gig of what they call GP2 root volume. GP2 is older version of SSD drives. We can switch that to GP3, which is newer version. And now I really want to go back to that free tier. As you can see, it's also here. Because the amount of storage we choose will also affect that free tier. And as you can see, it says I can have 30 gig of EBS storage if I want to be in that free tier. I will change that 8 to 30. You can leave it 8 as well, but you know, I can have up to 30, so I will change it to 30, why not? But I want to summarize it. If you've got up to 30 gig of GP2 or GP3 root volume chosen, and then if you have instance type that is free tier eligible, and if you have operating system that is also free tier eligible, then this server can run for 750 hours every month free of charge. And the next month and the following month, the amount of hours will kind of reset, and you will have new 750 hours for that new month. And if this is new AWS account and you've got 1 year of free tier eligibility, then this server can run for a whole year completely free of charge. It will not cost you anything, as long as you will not exceed any of those mentioned here. Alright, so let's go back. And well, that's it. There's nothing else I need here. I can just launch instance. So I launch instance and my server is being created. And it's now up and running. It says successfully initiated launch of the instance. I can click on that identifier for my instance. Instance means virtual server. And if I click on that, I can see Marek's server. And the status is initializing. That means it's not entirely full up to speed yet, but it's being created. And now if I click that button, you can see more information about that server. And one of the most important ones for me right now is my public IPv4 address. Public address means I will be able to connect to that server from anywhere in the world. Let me maybe refresh that first. Let's see if this... Okay, it's still initializing, that's fine. But even though it's initializing, you can try to connect to it already. I can click this button here, connect. And I've got quite a choice here. So first way to connect to my server, it's called EC2 Instance Connect. And if I click this button, this AWS console will take me to that server. And I'm logged on to this server. I can run commands now. For example, dfh is a command that will show me my root volume, that hard drive that we attached. And it says 29 gig and 1.6 gig is used, so I still have 28 gig available. That makes sense because we created 30 gig volume. So if I go here again and go to storage, and we can see it actually is 30 gig in size. Alright, so that's how it's done locally from AWS console. But what if I want to connect to it from my local terminal on my laptop? So let me just resize that. So I can type terminal. And this is my laptop, yes? This is terminal on my local laptop here at home. I can still go here, click that connect, but now I've got some hints. If we go to SSH client, it tells me what I can do to connect remotely from my home to this server. So it says open SSH client. Well, my terminal already has, or my system I should say, has SSH client. So next thing I have to do is locate my private key. Remember that key that we downloaded? I mean, it was downloaded automatically, that marekskey.pem. We can show it in downloads. Yes, it's in downloads. So here I have to navigate to my downloads folder. So I see the downloads. And I can see this is the file that was downloaded, marekskey.pem. Alright, so what I should do next? I should run this command, chmod 400 marekskey. I can click on those rectangles to copy that command, go back to my... One sec, let me make it bigger, and maybe clear that. Alright, now I can paste it, and click enter. What I should do next? Connect to your instance using public DNS. And example is here. So I will click that command, ssh I marekskey, paste it here, and this should take me to my server. And this is just standard warning. It asks you if you are sure you know what you are connecting to. This server is not known, so it asks you if you are sure you know what you are connecting to. But I am sure, because that's my server, so I type yes, enter, and now I'm also on my server, and if I type dfh, you can see exactly that this is my server, because it has 29 gig hard drive, I've got 28 gig available. That's exactly what we saw just a minute ago when I connected locally using AWS console. But this time, I can minimize that just to make sure it's clear. I'm connecting from my laptop that I have at home, and I'm connected to my server that is in AWS cloud somewhere. And I can run some like these devices. You can see this is my drive. You can run like what? HTOP. You can see the CPU utilization, memory utilization, and all that cool stuff. And if I run cat etc os release, I can see it is indeed Ubuntu operating system. Okay, that's how to create the server and how to connect to it from remote location. If you stop playing with your server, I would suggest you also destroy it here. Because once you destroy it, you also save those hours on that free tier. Remember, you have 750 hours. But if I now destroy this instance state, terminate. Yes, terminate. I am removing this server. As you can see, it's shutting down. And because maybe tomorrow I want to create 2 servers. And if total hours for all of my servers do not exceed 750 hours, I still will not be charged anything, because that 750 hours is overall amount for all services that I run here. So I can run 1 server continuously for a month, or I can run 2 servers continuously for, let's say, 15 days, or maybe 3 servers for 10 days. None of that will exceed 750 hours, so I still will not be charged anything. Hope that makes sense. Alright, and I will see you in the next episode. Bye. In this video, we will install VSCode, and VSCode is an IDE, which means Integrated Development Environment. And that IDE can help you working not only with Terraform, but also with Python or other programming languages. It can help you working with Ansible, YAML and other file formats. And while it's not a requirement to have VS Code installed when you work with Terraform, it is a very helpful tool, and it only takes like a minute or so to install. So let's see how it's done, and I'm sure you will like it too. It's a very popular tool, and it's very popular for a reason. So maybe in Windows first. Let me open my browser, and I will just search for VS Code download. Let's use first link at the top. And it couldn't be any easier. You just download version for Windows. You can see the downloader. Just wait a few seconds. Now we just run it. I accept the agreement. Next, next, next. And I will add the icon on the desktop and also make sure it's added to path. It should be ticked by default, so should be fine. So next, install. And if we click finish, it should also launch the VS Code. And that's what it looks like. As you can see, it has some highlighting, it has some auto-completion, and many other useful features. So as I said, it's worth having it installed. But now let's have a look at the Linux installation. This is my Ubuntu distribution. So again, I will just open my browser. But you know what? Before we do anything, maybe let me open the command line as well. And we always should really run sudo apt-get update. Done, and apt-get upgrade as well, just in case. But looks like I'm up to date, so I can close it. And now VS Code download. We will choose first link again at the very top, and now instead of Windows we choose Ubuntu, because that's my distribution. But you can see it's also a package manager for Mac. Like you can I will not go through the process on the Mac as well, because it's exactly the same. It's very basic. The only thing is, my Ubuntu is running on Parallels on my MacBook. That means I have to choose ARM version of this package. So I click this ARM64 Debian. Yes, I'll click on that. It's being downloaded. So I can click on it, software install, open. It says potentially unsafe as it's provided by third party, but I know it's safe, so I will install it. And we need sudo password. And it says preparing. Now the icon changed, so I believe that's all done. Close it, and I will just search for VS Code. We can see it's been installed correctly, so just open, and we will have the same window. It looks exactly the same as on Windows. That's all it is about VS Code installation process. The VS Code is now installed. Let's just add one small feature. Because we are going to work with Terraform, we will add Terraform extension to our VS Code. That's the real strength, the real power of VS Code. You've got those extensions. I mean, you click those 4 little squares here. It says extensions. So I click on that, and you will find loads and loads of different extensions, depending on what you want to work with. For example, here you've got something for Python. You can see it was downloaded 151 million times. And GitLens is another one that you might be interested in later on, but now we are just searching for Terraform. And you will find not one, but also many of them, and you can try them out. I mean, one of them can be better than other, and I personally used first 2 of them. You can see one is from Anton Kulikov and one is directly from HashiCorp. So today we will just try that official one from HashiCorp. You can see in the review it has only 2.5 stars, but I'm not sure why, because it's not bad really. I've worked with it and I found it, it works as expected. So let's install it. We just click that little install, and that's it. It's been installed. After a while, that's now completed. And it will also tell you what it does, this extension. It says syntax highlighting and auto-completion for Terraform. And that's perfect. That's what we need, exactly. You will see what it looks like once we start using it. That means now we are ready to start working with Terraform. We have VS Code, we have VS Code Terraform extension, so now let's prepare our workspace where we will save all our work. For example, you can open a terminal and decide I am in a home parallels, that's fine. What's here? I don't think there is anything interesting. So I will create a new folder and I will call it Terraform. Make dir Terraform. So in my home folder, I will have a folder called Terraform. This will be my workspace. I will just close it. Here we can click that top icon, the Explorer, and we can click Open Folder. And we will open that folder that we've just created, the Terraform one. Let's open it, and it should be empty because we've just created it. Yes, I trust. This is my device. Maybe I will make it bigger. And we can configure our provider. I already mentioned previously that provider is that bridge that connects Terraform with that space where you want to create that infrastructure. And we want to work with AWS, so we need AWS provider. And to do that, let's Google what that AWS provider should look like. I will Google Terraform AWS provider. At the very top, we've got AWS provider HashiCorp. Let's click on that, and that's it. They say that's how it's done, but they also have the resource here. We are not going to create a resource yet. We are just interested in the provider itself. So let me just copy this part with Command C. Now let's go back to VS Code, and in my folder, I have here little icons, new file, and I will create a new file, and I will call it provider, and I will add extension .tf. And as soon as I've done it, have a look, the icon changed on the left, because if I click enter, I've got a new file, and VS Code detected, exactly it was that VS Code extension we installed. This extension detected the Terraform file, which we can also see here in the bottom right corner. It can see we are working with Terraform. Let me now paste the portion I copied from that website. So this part will tell Terraform what we are working with. And please note that you can have multiple providers. Maybe you work with AWS, but maybe with Azure as well, and maybe with Proxmox. You can paste here multiple providers, but in our case, we are just going to work with AWS. So that's the only provider I need. But it is possible to specify more than one provider here. And here it says configure the AWS provider, and you might already recognize this portion. Region is something we already specified previously when we worked with IAM groups and IAM users. We specified the AWS region, and I specified EU West 2. Let me just press Command S on Mac or Control S on Windows, it would be. So Command S to save this. And I will click that terminal. I will say new terminal. It will open here. And now, if I type AWS configure, this is something we already did in the past. We configured the access key. We configured the secret key, which is kind of like user and password. That is what Terraform will use to be able to access the AWS cloud. But then, if I click enter again, I also specified the default region. EU West 2 is London, actually. But maybe you want to create your resources in different region. Or maybe even I want to create this, like next resource we're going to create, maybe I want to have it somewhere else. This is the way I can override whatever I specified here. If I leave this setting as it is, that means my resource, for example server, will be created in US East 1. So this, if I remove it, then it will use the default value, which is EU West 2. I hope that makes sense. And there was also output, but we didn't say what's the default output we are interested in. What I will do though, I will match here, I will leave this entry, but I will match what I have as a default region as well. But I will remember this is the place where I can override that value. So Command S again, and that's it. We've got our workspace, it's this Terraform folder, and we've got the provider configuration saved. Now let's talk about Terraform init command. Terraform init is the first command we want to use if this is a new workspace and we never previously worked with Terraform. So we have to initialize everything. Let me just run this command and you will see what I mean. I basically just run terraform init. That's all it is. Let's press enter. What you can see, it's initializing the backend, it's initializing the provider plugins, and it will tell us everything what it does. You can see it's installing HashiCorp. Oh, it's already done. It doesn't take long, but what you can see here is that the provider was installed, has been installed. It's version 5.83.1. We can see Terraform has created a log file. It's called Terraform log HCL, and we can see this file here. Remember, we only had Terraform folder and one file. But have a look now. We've got another folder. It's a hidden Terraform folder. There are some more files, and we also have that Terraform log. So in that folder, Terraform downloaded all the binaries that it needs to work with AWS provider, and Terraform log is like information for Terraform which version of those binaries were installed. We can see it's version 5.83.1. That's because the constraint we gave Terraform is that it was supposed to be version 5 or higher. So it downloaded version 5.83.1. What I mean, if we go to that provider file, we can see we stated we need version of AWS provider that is higher than version 5.0. So Terraform downloaded the latest one, which is 5.831. So this is simply like additional information about those binaries that are in that .terraform folder. That's great. We should now be ready to create our first server in cloud using Terraform. I logged on to my AWS account. The region we mentioned already is here. So EU West 2 is London. Initially in the provider config we had US East 1, which was North Virginia, but I want to create my resources close to where I live, so the closest for me is London, EU West 2. So this is basically what we have in our provider.tf file. I said I want them in region EU West 2. And we already initialized our Terraform with AWS provider, so it should be able to work with AWS now. So how do I create server here? As we can see, we have no instances. Instances means virtual servers, and virtual server is also called EC2 in AWS, Elastic Compute Cloud. And everything we create in AWS is called a resource. So what I can Google now, I can Google Terraform EC2 resource. And the very first link, it says AWS instance. Well, that's exactly what I need, in fact. If we scroll down, we will see many examples of how we can create an instance in AWS. But let's go back to the top, to the very top. Basic example using AMI lookup. But you know what? I will make it even simpler. We are not going to even use AMI lookup. I will just hard code the AMI. I will show you what I mean. I will basically just need this, like 5 lines of code, and I will just Command C on my Mac to copy it. I will go back to my VS Code and I will create another file here, new file. I will call it server.tf. It's again Terraform file. I will paste it here. So what's that? First word is resource. As I said, anything that we want to create is called a resource. The second part is what type of resource it is. And it's AWS instance. Instance means virtual machine, or in other words, Elastic Compute Cloud, EC2 instance. That's how AWS calls it simply. That means we are going to create a virtual server. And this is the name. I can call it whatever. Let's maybe change it. Not web, maybe not web server. I want to call it Marek or Marek's server. I can call it whatever, doesn't really matter. And the AMI is something I can specify myself. What is AMI? We already dealt with AMI, not sure if you remember, but if we go to AWS, we were creating a server manually. We then clicked that launch instance, and this is where we choose our operating system. And we chose Ubuntu there. Every operating system here will have Amazon Machine Image ID. This is this Amazon Machine Image Identifier. AMI 05 blah blah blah. You can see it also here. And every single operating system, well, for example Red Hat, it will have different Amazon Machine Image Identifier. So if we go to Ubuntu, maybe I want to build my server based on Ubuntu operating system. So this is the identifier I need, and I can simply copy it and paste it to my code. I just have to add it here, but I have to add it as a string, data type string, which means I have to use double quotes. And I use Command V to paste the Amazon Machine Image ID. Next is the instance type, and it's configured to T3 micro by default. That's what we copied, I mean. But if we go back again to this AWS account, we can see, remember that free tier eligible we were talking about when we were creating AWS account. If we check the T3 micro doesn't have that free tier eligible tag. That means we will pay for that. If you have new AWS account, you've got that free tier, so I would suggest to use T2 micro instead, because that's part of free tier eligible services. So let's go back, and I will change that T3 micro to T2 micro. And then the tags, this name tag is simply what you would put here, where we were choosing a name for our instance. So I will change it, you can leave it of course, but I will change it to what? Marek's first server. Alright, and now I just do Command S, and I have saved everything that I need to create my first server. Okay, we have everything we need. So how do we create that server? Let's first go back to our AWS. Let me go back to show the number of instances. As you can see, we have no instances running, which means we have no virtual servers. If I click on that, you also have to make sure you are in correct region, yes? We are going to create our server in London, which is EU West 2. So let's monitor it. I will just leave it as it is, and we have no running instances. I can even remove that, which will show me all instances, even if they are stopped, but we still don't have any. So now I will go back to my code, to VS Code, to my terminal. I will clear it maybe. And first command I might want to run is called Terraform plan. And Terraform plan will show me everything it's going to build in AWS Cloud, but it will not apply those resources, which means it's only information for me. Let me just run this command and you will see what I mean. I click enter and the plan is being created. Alright, that's the plan. Let me make it bigger. What it says? It says that Marek's server will be created. The AMI will be this. That's because we specified that. It's the Ubuntu AMI. The instance type is T2 micro. And the name will be Marek's first server. And everything else, Terraform says it will be known after apply. It doesn't know yet what it's gonna be. Once we apply that, only then we will find out what's the value for example, for public IP, etc. So if we scroll further, the plan is for one resource to add, because we're creating one virtual machine, 0 to change and 0 to destroy. We will see that later on, what it does. So let me clear again, maybe. And now, if I do up arrow, instead of Terraform plan, I can run Terraform apply. What apply does, it basically will run Terraform plan anyways, first of all. But then we will see the difference. Let me click just enter. I will click enter. We can see exactly the same plan as with Terraform plan command, but now it asks me, do you want to perform these actions? Terraform will perform the actions described above. Only yes will be accepted to approve. So if I say yes now, Terraform will create a virtual server for me in AWS Cloud. And that's what we need, yes? So let me click enter and let's see what happens. Let's wait for a few seconds and it says the server is being created. That's it. 13 seconds. And we've got the instance identifier, which is identifier for my virtual server. We can see it ends with 8CE. So let's go back to our AWS and let's refresh it. Have a look. 8CE, instance ID. This is my server. It still says initializing status check, but it's already there. Instance state is running, and all this information like public DNS, public IP, etc. Remember, Terraform couldn't figure out what it's gonna be. And because we didn't specify those details, it's simply randomly chosen by AWS Cloud. That's it. That's our instance up and running. And if you are interested, let me clear that again. What now happens if I run Terraform apply again? What do you think will happen? Let's have a look. I will press enter. Terraform checks what's in the code, what's in those files, and it can see there is one server that we want to have. And this server is already up and running. Terraform can compare what's in the cloud and what's in the code here. And if the desired state is matching, like this is called declarative. You declare what you want to have in the cloud. Like I want to have one server, and that one server is already there. It's up and running. So Terraform says no changes. Your infrastructure matches the configuration. Whatever we configured here is already in the cloud, so there is nothing to do. And that's very important to understand. We are going to create more of those files with different resources, and if one of them is missing, for example, Terraform will only recreate that one that is missing. So the infrastructure will match the configuration again. It's always the desired state, yes? And that state is now kind of confirmed. So there is nothing for Terraform to do. So we have our instance. It's up and running, yes? Instance, I mean virtual server. If I refresh it now, status check also changed. It says both checks have passed. My instance is running and it's cool. But what now if I want to remove my instance? I don't want it to be running any longer. I want to destroy that instance. And remember, when we did it manually, we chose that instance state, terminate, delete instance. But in Terraform, I use the destroy command. So I simply say Terraform destroy. And Terraform destroy will simply remove whatever we have in our code. Let me run it to show you. I click enter. And before it destroys anything, it will ask us if that's what we really want to do. Do you really want to destroy all resources? Well, we've got only one to destroy, as you can see, because it also creates a plan, but this time it's a destroy plan. And if we scroll further up, we can see AWS instance Marek server will be destroyed with this AMI, but you can see now Terraform holds much more information about that instance, because whatever AWS cloud assigned to us, Terraform is aware of all those, values. This is our public IP, etc. So if that's the instance I want to destroy, I just say yes. And I click enter, it says destroying that instance. Oh, it took a while, 41 seconds, but you can see it's now been destroyed. And if I go back to the console and refresh it, we can still see that instance, but the state is terminated. And this will disappear after a while, but this is just a confirmation that this instance has been just removed. So let's say now I want to quickly build another instance. If I do Terraform apply again, I will say yes. Now another instance is being created for me by Terraform, but this instance will have different identifier. That was quick, 13 seconds. And now we can see it ends with 0EA. So if I go back, refresh again, now we will have two entries, but only that 0EA is running and the previous one is terminated. And that's how you create and destroy resources using Terraform. And let me destroy this one as well, because I don't need it up and running. I will say destroy, say yes, and this new instance, that 0EA, is also being destroyed, which means I will shortly have two instances with state terminated. This one for some reason took much longer, 1 minute 31 seconds to destroy, but eventually it was destroyed. So if I refresh, we can see two instances, but both are terminated. So now let's think about it. We had that server created in AWS, yes? And this server had some private and public IP address. Where these addresses come from? The private IP address is actually part of VPC and part of a subnet. Because AWS, let's go back to AWS and let me duplicate this tab. AWS creates a default networking for us. All the network is created for us in the background, because if I'm not a network engineer and I just want, for example, to run one web server, maybe I'm not worried about all the networking behind it. Then the AWS will put that server in that default VPC in some default subnet. Let's search for VPC. It's a service VPC, Virtual Private Cloud. This is basically a space where everything, all your resources will be placed, unless you specify otherwise. And this is it. You can see VPC ID, you can see the IPv4 CIDR, which is the IP prefix. So our server had private IP assigned from within that IP prefix. And we have some routing table, DHCP option, blah blah. And if I duplicate it again, you can see that VPC, if we click on that VPC, you will also see 3 subnets created within that VPC. and our server will be allocated in one of those subnets. You can see subnet EU West 2A, 2B, and 2C. Let's click one of them, maybe 2A, and they will have different IP prefix. Again, this is smaller IP prefix. It's a prefix that fits within this larger prefix of the VPC. I know it's not AWS training, and it's not computer networking training, but I just want you to know that by default, our server will simply be placed in that default VPC and one of those subnets. But that doesn't mean it has to be like that. We can create our own VPC, our own subnet, and we can state that we want our server to be placed in one of those subnets that we are going to create. But what's even more interesting, and that's what I want to show you really here, is that the Terraform will have to resolve some dependencies. And I know it might be a bit confusing at this stage, don't worry about it. You will understand what I mean when we start working with that. Let's go back maybe to VPC. We can see one VPC, it's only that default one, and it has CIDR of 172.31.00/16. But we are going to create our own VPC. So I go back to my Terraform. I will create maybe new file. I will call it vpc.tf. And now we can Google how to create. I will Google Terraform results AWS VPC. Virtual Private Cloud. And the first one at the top is the one that I need. And we've got some examples. I could use this one, but I can see the second one has a name also, so that's something that's already included. So maybe I will use this. I will just copy it here, clicking this button. I will go back to my code and I will paste it here. Maybe we'll make this smaller. The CIDR block is this, IPv4 CIDR. The default VPC has 172.3.1.0.0, and in that code we've got 10.0.0.0/16. It's fine, we can leave it as it is. And VPC, I will call it not main, but I will change it maybe to Marek, or you know what, my VPC. My_VPC, something like that. Then we have instance tenancy. I'm not sure why they added this. If we go back to VPC resource, if we scroll down, you have argument reference. It's basically showing you what you can add here, what you can specify, and as you can see, instance tenancy is optional, so it doesn't have to be there. And anyways, default is default. If we didn't have anything here, the instance tenancy would be set to default anyways. But it doesn't matter, it can be left as it is. But name, for my VPC, the name that will be shown in AWS actually, I will change it to my VPC, something like that. And I will Command S to save it. And just to test it, I will go back to my server, but what I will do, I will comment it out. So I'll use Ctrl and / to comment everything out. I will save it. This will be seen by Terraform as a comment, so it will be ignored simply, because I want to concentrate on my VPC only now. And I just want to test if it works as expected. So I will just run Terraform plan. And you might be wondering, the other thing is, you might be wondering, Marek, you don't have the provider or anything, where is it? Remember that provider is actually a separate file, and it doesn't really matter that it's separate file. The thing is, I am creating separate file for everything. Separate file for server, separate file for VPC, and for provider. But in fact, you could have all the configuration in just one file, called whatever.tf, yes? It doesn't matter what you call it. It only has to have the extension of .tf. But Terraform actually reads everything that is inside that folder, in that workspace we created, in Terraform folder. So it doesn't matter if your configuration is in one file or in 100 files. Terraform will read all the information from all the files first, and only then it will start acting. It will start creating whatever you have in those files. So that's very important to understand as well. What I also wanted to point out is there is a new file called Terraform tfstate. It was created when we created our server, and we will talk about it shortly because it's a very important file as well. But for the time being, we are just creating the VPC, okay? And the provider is already specified in separate file, but it will be read by Terraform. Anyways, alright, so I will run Terraform plan. Let's see if it will work. And yes, looks like it does. One to add, because I commented out the server, that means I'm only creating the VPC. And we can see the 10.0.0.16, the instance tenancy is default, and maybe let's have a look, ID known after apply. Also ARN is known after apply, etc. There are many things that are only known after this resource is applied. I mean, it's pushed to the AWS and actually created there. That ID is very important because we will need it later on when we create our subnet. But for the time being, let me just rerun the command, but I will now apply. And I will say yes this time. One to add, yes, that's my VPC, and it should be called my VPC when we see it in AWS Cloud. So yes, shouldn't take long. It's already done, 2 seconds. So if we go back to VPCs, and if we refresh that site, that page, now I've got my own VPC, and it's named my VPC, and the CIDR is 10.00/16. And this VPC ID is what I mentioned. VPC ID, Terraform said it will be known after apply, because that's something that AWS creates for us, and Terraform can only read it once this resource is actually created and it's in the cloud. Why I was talking about that VPC ID if we haven't used it anywhere yet? Well, that's because we are going to use it now when we create a subnet that will be part of this new VPC. Because if we currently go to subnets, you can see them here on the left under VPC. If we go to subnets, currently we've got 3 subnets, but even looking at the CIDR, at the IP prefixes, we can see they belong to that default VPC, because the IP addresses start with 172.3.1 something. And we also can see here that they all belong to the same VPC, Virtual Private Cloud. We created our own VPC, but we haven't got any subnets there yet. This is my VPC, but it doesn't have any subnets. So let's create one. Let's go back to our code. And maybe before I create another file called subnets, maybe we will add it here first. I will show you the reason for that. I will go to Google. We are looking now for Terraform resource AWS subnet. Alright, will be this link. And this is how I can create my subnet. But if we check maybe a little bit further, you can also specify availability zone ID. It is optional, but it's something you... Well, one second. I believe if we go back to instances, I know it's not the resource we're looking for, but if we scroll further, I believe... Yes, have a look. This is the subnet, but it also has specified availability zone. In fact, it also has separate network interface where we can specify IP address for our server, and this is the configuration for the server itself. You know what, that's cool. Let's use all of that, really. So first I need my subnet. I will copy just that. Let me first paste it here, though. I want to show you something. We added a subnet here, configuration, and it's called my subnet. That's fine, we can leave it. We can call it whatever we want. But where is this name even used? If I hover over, it says reference name. This reference name, for example, this my subnet, is used if we have to reference this portion, this resource, in some other resource. And look, it already happens here in this line. For example, I want to create a subnet, but that subnet is part of larger VPC. And in fact, I want my subnet to be part of this VPC, this resource. What I mean, if I call my resource, for example, Marek, then this reference name will have to be changed here as well. Somebody might think, what's going on here? Why is it done like that? Remember that ID, the VPC ID is only known once that VPC actually exists in AWS. So Terraform has to create the VPC first. It has to wait until AWS assigns VPC identifier, which can only then be referenced here in this line. So we are saying we want this subnet to be part of VPC resource, and that resource, we called it Marek. That's our name for that resource, reference name. And Terraform needs only ID, because AWS will provide ID, ARN, blah blah, many different things, but we need only to reference ID here in this line. So that's why if we go to that instance, we can see in this example, we only need the ID. So whatever I call this VPC, let's put it back, my VPC, I also have to then change this reference name here. Again, my VPC. It has to match. Imagine as if I removed those quotes and just put dot here, yes? Something like that. AWS VPC my VPC ID, AWS VPC dot my VPC, and then I only need dot ID. I know it's confusing, I understand that. This is all done this way, so Terraform understands that it will have to create VPC first, and it will know that because that VPC is referenced later on here in this line. It creates so-called dependency tree. Alright, I know. Now CIDR block for my subnet. Let's say I want 10.0.1.0/24, and because we create everything in EU West, not US West, I have to change here the availability zone to EU West 2A, because we have 3 availability zones, A, B, and C. And the name I will change to my subnet. I will run command S. Let's run Terraform apply, maybe clear first. And it says 1 to add. Aha, because we didn't actually destroy the VPC. The VPC is still there. It only will add subnet in this case. And you will see that subnet will also have its own identifier. And it's also known only after apply. So maybe for the time being, let's just run it. Yes. And it's added. That was 1 second, getting quicker and quicker. So now if I go to subnets, I should have one more subnet, my own subnet. And here it is. It's called my subnet. It's part of VPC my VPC, and the IP prefix is 10.0.1.0. But before I forget, let's now destroy all of them. Terraform destroy, and I say yes. 2 to destroy, because we will destroy VPC and subnet this time. Yes, have a look at the plan. VPC will be destroyed, and note that Terraform knows what is the ID now, because that VPC has been created. It finishes with 166E, and indeed my VPC ends with 166E. And the subnet also got its own ID, but it's, it looks completely different. Finishes with 71B. So if I go to subnets, we can see that indeed it's 71B. It's this identifier. And they both will be destroyed now. So I say yes, enter. And we've got 2 destroyed. So if I go and refresh, we are back to that default VPC. And subnets, if I also refresh, we have only those 3 created by AWS. Now if we go back to our code, remember that we commented out that server, yes? Let me uncomment it with Ctrl// and Command S. And we were looking at that example in AWS instance. And we have our VPC, we have our subnet already, and this instance, we can see it has that additional thing, network interface, where we can specify what private IP we need assigned to that virtual server. So let's copy this portion as well. Let's go back to our code. For now I will paste it below, maybe make it bigger. Now I already have AWS instance. The only new thing here really is that network interface. So let me copy that portion and I will paste it in my instance. That's it. That means I don't need this thing. I can get rid of that portion. So what we have now is exactly what we used to have, but with that network interface added. And this network interface again has that dependency that Terraform has to resolve, because network interface ID is AWS network interface.foo.id. What that means is that Terraform has to create this resource first. And notice, when I highlight this portion, VS Code also highlights that portion. It knows that extension, we installed for Terraform, it knows these two are related. The same, if I highlight this foo, these are those dependencies, yes? That's why it's much easier to work when you've got that Terraform extension added. So again, if I change this resource name to, let's say, Marek, then I also have to change it here to Marek. And Terraform knows that it will have to create that network interface first, because this ID will be only known once this interface has been created. And now private IP, I can choose whatever I want, but it has to be part of my subnet. So 10.0.1.maybe20, I say. Why did it say 10.0.1.20? Because again, that network interface has another reference, another dependency, and it's AWS subnet, my subnet. If we go back to VPC, we can see this resource here. AWS subnet, my subnet. We can see it's in different file, but as I said, it doesn't matter. Terraform will read all the information, everything that is inside this workspace, inside this folder first. And this subnet has a prefix of 10.0.1.0. That means my IP address, my private IP address, has to be within that scope. And 10.0.1.20 is within that scope. And then the name, maybe I will change it to my interface. So as we can see, we've got more and more dependencies. First, it will have to, let me maybe Command S, and the Terraform will have to first create the VPC, because VPC is already referenced in subnet. Once it creates the subnet, this subnet is then referenced here in network interface, and then that network interface will belong to my server. And we are ready to run, but before we do that, let me go back to VPC, because this subnet, we can also just cut it from here. And I will Command S, and I will create new file, and I will call it subnet.tf, and I will paste it here. And in fact, you know what? I will show you how easy it is now for us to create second subnet if we want to. So wherever you are, whatever you want to copy, whatever you want to create, you can just copy it, paste below, and for example, I will call it my subnet 2. It will be part of the same VPC. I will change the CIDR block to 10.0.2.0 maybe, and maybe I want to have this subnet also in different availability zone. So I maybe change it to B, and I will also call it my second subnet maybe, or something like that. And this one I will call my first subnet. And that job done. I will Command S. Now let's see if I messed up something. Let's clear everything, and I will run Terraform apply maybe. As we remember, apply will also create a plan anyways, so we will see if everything is fine or not. So I will run it. Looks like everything is fine. It says 5 to add. And what it's going to add? Let's go back to the very top. And what you may find interesting, it says first that we'll create Marek's server, yes? Well, that's not true. It's simply, at this stage, it didn't resolve these dependencies yet, but you will see very soon what I mean. If we go further, we've got the instance, yes, we've got that server, then it will create network interface for that server as well. As we can see, it's here. It will create the subnet. It will create second subnet and VPC. However, when we run it, I say yes, just if you concentrate, I click enter. It will start from VPC, and then it will do subnet, as we can see. Then it will create network interface. Then it's second subnet, because second subnet wasn't referenced in that interface. So it doesn't matter when it's created, that second one. But first subnet had to be created before interface was created. And server was created at the very end because all those dependencies had to be resolved. That server had that network interface, which was part of this subnet. That subnet was part of this VPC. That's why it had to do it in order. Alright, let's check if we have everything we wanted. VPC, I will refresh. Indeed, I've got my VPC with that IP prefix. We go to subnets. I refresh. We've got two subnets, my first subnet and second subnet. And if we go to instances, let's refresh. We've got Marek's first server. Well, it's not first, but that's our tag. But you can see it has private IPv4 address of 10.0.1.20, which is exactly what we specified here in our server portion. That's our private IP. Everything works as expected, so we destroy stuff. I will clear and I will say Terraform destroy. And it also will be removed in some order. Checks everything and it says 5 to destroy. Yes, that's exactly what I want to do. So I say yes, enter. And it starts with subnet 2, which is not referenced. Then Marek's server with the interface. Now the interface itself. Then the subnet that was referenced by that interface. And the VPC at the very end. So the order is exactly opposite to what it was when we applied, yes, that infrastructure. Hope that makes sense. So we know how to configure multiple resources and how one resource might depend on another resource. Like here, this network interface will only be created once we have subnet created. But how Terraform knows what is created in AWS Cloud already and what is not? And that's all about this Terraform tfstate file. When you create something in the cloud, the AWS will produce like a bunch of information about that resource, and Terraform will then store it here locally. In this case, we store it locally on our computer. And as we can see, this file is now very short. But let's now recreate our infrastructure again in the cloud. So I just run Terraform apply, and we will see how this tfstate file changes. So I just press enter, and it says 5 to add, because we will add VPC, subnets, and the network interface plus our instance. So I say yes, that sounds about right. So click enter, and this infrastructure is being created. You can see the differences already. Something is being written to this file. And now the process is completed, so let's have a look what's in that tfstate file. As we can see, it's much longer now. Look at that. It's loads and loads of information about the resources that were just created in our AWS cloud. For example, I can see there is loads of info about my VPC, for example, like what's the CIDR block, what's my routing table ID, network access lists, etc. And the fact is, you usually don't read that information directly from this file. It's not really user-friendly, it's just amount of information is basically just overwhelming. What you would do instead, you usually here, let me clear, you would run like Terraform state, and then we can do --help. So we want information about our state file, this tfstate file. So we've got subcommands like list, show, remove, push, etc. Let's see what list does. Terraform state list. And what we have here, they are our resources. Because we can see we've got one VPC, we've got two subnets, interface, and the instance. So if I want to get more information about my instance, for example, I can do Terraform state show, and now I will copy just that. And it will display all information regarding my instance, so about my virtual server, yes, in the cloud. And now, all this information is kept in this tfstate file. So if I run again, let me clear again. If I run now Terraform apply, what do you think will happen? Let's press enter. Terraform was refreshing the state, means it contacted AWS using those API keys we created. It checked what is already there in the cloud, then it compared that output to what it has here in this tfstate file, and because everything matched perfectly, it told us no changes, your infrastructure matches the configuration. And this tfstate file currently is kept here locally on my laptop, yes? The problem is, it's usually the case, especially in bigger companies, that you are not the only person responsible for maintaining that infrastructure. There you might have, I don't know, 5 or 10 people working, maintaining and upgrading the same infrastructure. So what you do usually, you send those files like provider, server.tf files and vpc.tf, you would keep them remotely in GitLab or GitHub, let's say, so all other members can download those files, so everybody or every member has exactly the same code. But now let's think what happens if both me and one of the other members start changing something in that infrastructure. For example, I want to change something regarding my server, while other person wants to change something regarding the subnet. That might cause a problem, because my server depends on what is in the subnet, yes? If something in the subnet changes, it will affect my server, because we remember we've got that network interface, and that network interface is dependent on the subnet configuration. So basically, what we need, we want only one person at a time to work on this infrastructure. Even if both people do some changes, only one person should be allowed at a time to change the infrastructure. And once one change is completed, only next change can happen. And we can use that tfstate file to achieve, to use it as a solution to that. If we work in a team, this tfstate file is not kept on my laptop. It should be kept somewhere remotely where it can be constantly updated and it can be locked. So if one person works on the infrastructure, that person will lock this file so nobody else can read or write to that file. the other person would have to wait, till I, for example, finish my changes, this file is updated, only then I will unlock it and the other person can take over and lock the file again. So how we do that? Well, there are many ways we can achieve that, but because we are working with AWS, the most common solution is to keep this file in S3 bucket. It's simple storage solution within AWS where we can store the files. And I can show you what it used to look like. We have to have new segment like Terraform backend. We call it S3. It's S3 bucket within AWS. And this is the bucket name where we want to store our tfstate file. We want to store it encrypted, or you know what, maybe it should be encrypted, but let me remove that for now. We might want to have a look inside that, so yeah, I will just remove it, but it should be encrypted basically, yes. In region EU West 2, because everything else is kept there, so why not? But then, as I said, you have to have that lock mechanism for this file. And we used to have separate DynamoDB table. DynamoDB is like a miniature database, let's call it. And when anybody opens a file in that database, this entire file is locked. So that was the mechanism that we used to use to lock the tfstate file in S3 bucket. But that also meant that we have to maintain one more thing in our AWS infrastructure, which was that DynamoDB. So with the newest Terraform from version 1.10, and you can check your version running Terraform version, you can see I'm on 1.10.4. So from 1.10, there is a new way of doing it, and you can replace that DynamoDB with useLog file. As you can see, Terraform extension helps us with that. We've got this auto-populated, so let's click on that, and we want it to be true. We want to use it, that log file, locking mechanism, within S3 itself. Alright, so that should be it. I will just command S, and now I need this bucket to be existing in AWS, so let me copy this value, because I don't have that bucket. So let's quickly create one, and I will go to S3. Bucket is like a placeholder within AWS where you can just simply store stuff. I've got some buckets, I don't remember what they are for, but I will create a new one. I will paste that name here, and scroll down. It's also advisable to enable bucket versioning, so all the older versions of tfstate file will be preserved. If somebody overwrites this file with something incorrect, you will be able to go back to the previous version of that file. But that's up to you. It's advisable though to have it enabled. And I just create the bucket. The bucket is here, so I just go back to my code, and what I have to do, I have to run Terraform init again to initialize entire repository. So I run Terraform init, press enter. Initializing the backend. Terraform noticed that we are going to change the entire backend configuration where the tfstate is kept. So it asks me, do you want to copy existing state to the new backend? Yes, that's what I want to do. Alright, initializing, successfully initialized. So from now on, if I go to my bucket, if I click on that, we can see why this prod is here. That's what I added here in the key. For example, you may call it prod, dev, test, or you can call it whatever, because maybe, I don't know, you want to keep tfstate file for various environments in the same S3 bucket. So maybe you don't want to keep just Terraform tfstate, but also information what environment it is for. So that's why I added prod, but it's optional, it's up to you really. So now if I go to that prod, this Terraform tfstate file is from now on kept here. And if I start working on that, if I do any changes, this log file will prevent anybody else to do the changes at the same time as me. Only one person will be able to do the changes at a time. So I hope it makes sense. Now let's talk about variables. Nearly every programming language has the concept of variables, and HCL from HashiCorp Configuration Language is no different. It also has concept of variables. So let me first destroy, or run Terraform destroy, because we forgot to destroy it. Also, you can add auto approve. So it will not ask you if you want to do that. Yes, I'm sure I want to do that. So we can add auto approve. Let's destroy that previous configuration, that previous infrastructure, and let's talk about those variables. Let's have a look at the server configuration. I've got this instance. I've got the network interface for it. And so maybe in this situation, it's not that clear why we would want to use variables. But let me change to what we used to have previously. We had something like that, yes? Our config was much simpler. And we had multiple instances. I will copy that, paste it here, and this will be, let's call it my server, a bit shorter, my server 1, my server 2, and also here, my server 1, my server 2. And if you had any experience with any programming languages, you know that you would use variable in any place where you have repeated information. And what's that repeated information here? Well, I can see two. It's AMI, because we have it here for one server, for server number 1 and server number 2, plus instance type. It's T2 micro. Because if I wanted to change that instance type, I would have to go to every single line and replace it with T3 or T3 there, etc. Yes? Well, with 2 servers, maybe it's not a problem. But what if I have 1000 servers? So that's where we can use those variables. And how do I use variables with Terraform? With HCL? What I can do, I can copy, for example, my AMI, let's copy it, and I replace this value with var dot, and let's call it my instance type. I could call my variable also AMI, but I want to make it different, so I want you to clearly see what is going on here. And then, at the top maybe, I will add another line, I will call it variable, and my variable has to be in the quotation marks, and I called my variable my instance type, and I will use curly brackets. And within that curly brackets, I can specify the default value. I say default equals, I will copy paste my AMI. However, I want to have it as a string, which means I will add quotation marks again. So we basically have the same thing, but now it's stored as variable. And now I can replace all of those lines that have AMI with value of that variable, or with that variable name, I mean. Let's replace that instance type as well. It's T2 micro currently. So I will say I want to create new variable, and I realized I did something stupid. It's not really instance type AMI, yes? My instance OS, let's say. Let's call it my instance OS and my instance OS, because it's operating system, yes? AMI, it's operating system, and I want to call my instance type my instance type, yes? That's more accurate. Or maybe I will call it just EC2 type, just so it's different. And also here, EC2 type. So now I create another variable. I called it EC2 type, and I specify the default value here. Or you know what? Maybe I don't. What if I don't? Let's see. Command S, I saved all of that, and see what happens. I've got default value for AMI, but I don't have default value for EC2 type. So let me clear again, and let's run Terraform apply. Press enter. We can see Terraform found the variable for AMI, but it couldn't find the value for variable called EC2 type. So it simply asks us, enter a value. What do you want this variable to be configured to? So I'm saying T2 micro. Once I click enter, Terraform now should have everything it needs. And it says again 5 to add, and if we check what it wants to add, we can see it wants to add instance type where the type is T2 micro. Alright, but I say no, apply cancelled, and I want to specify that default value. So default equals T2 micro, and if I command S again, if I run Terraform apply now it has all the information it needs. It doesn't have to ask me for the value for that variable. It goes straight to this stage. Alright, but I say no again, because that's all I wanted to say about variables. Now, when we talk about the variables, there is one more file that you might be interested in, and it's a file with tfvars extension. So let me show you. Let's call it maybe Terraform, but we will use .tfvars extension. So not tf, but tfvars, yes? And this file is only to keep the variables. But somebody might ask, Marek, but we've got the variables already, yes? We've got them here, so what's the point of another file that will keep only variables? Well, there are various reasons that you might want to use the tfvars. Let's say, what if I have variable that is very important for me, like password, yeah? And then maybe you've got default value as well, my secure password. Maybe that's something you don't want to keep in GitHub or GitLab and share with just anybody, or anybody who has access to GitLab will also see those passwords. So what you can do, you can just leave it blank. That's what we did with EC-type initially, remember? You can maybe keep this password blank and instead go to the tfvars and only say password equals my secure password. And then maybe you want to keep this tfvars somewhere else in some kind of vault that only some engineers or maybe only you have access to. So nobody else will be able to grab this information. But also maybe you want to have the tfvars to simply be able to override in easy way the default values that you have in variables, yes? So let me show you what I mean. Let's remove this password maybe, and let's stick to what we already have. I will remove this. We've got EC2 type. Note also there is a, so I can simply, maybe I will just want to change the EC2 type. I'll just copy it. The notation is slightly different. I think you noticed already. If we go to tfvars, I will just paste it here. I'm not saying it's variable and it's not in quotation marks because we already know it's variable. It's tfvars. It's only for variables. So I will only say equals, and then as a string, I will keep maybe R4 large. That means I want to overwrite whatever is in this file. The default value is T2 micro, but I want to overwrite with R4 large value. So let me just command S. Let's see, clear. And if I run Terraform apply, let's see what happens. We've got 5 to add, but what is it? And we can see it wants to create the instance, but this time the instance type is indeed R4 large. And be careful with that, because this is not free tier. You would have to pay for that, yes? But if I say yes, the instances have been created, and if we check them in the cloud directly, refresh, I can see they are no longer T2 micros, they are indeed R4 large. But to be on the safe side, let me destroy them immediately. So it might cost me, but it will be negligible amount of money. Terraform destroy, auto approve. Now let's say I want to create not one, but I want to create 100 servers in Terraform. Yeah? How do I do that? Well, maybe first of all, let's get rid of that. I don't want to have them as R4 large. So, or maybe you know what, I will just remove entire file. We don't need it anymore. Move to trash. So T2 micro is our free tier default value for the instance type. Okay, and now I want to create 100 servers, yeah? Somebody might say, yeah, Marek, you just have to copy this like 50 times and it will give you 100 servers, yes? Well, that might be the solution, yes, but definitely not something we want to do in Terraform. In fact, I don't even need 2 of them. This is already like repeated information. I only need really one resource, AWS instance. I can call it just my server. This we can leave it as it is. And I can use something called meta argument. Let me command S to save this. And let's Google Terraform meta argument. And I don't need depends on meta argument. I really need count meta argument. But let's maybe click this one. And in the Terraform documentation, you can see many different meta arguments. And the one that I'm interested in is, as I said, count. Although we could use actually for each as well, but I will use count this time. So what I want you to notice as well, at the same time, you not always want to go to Terraform resource AWS. What you should really do, you should go through that Terraform documentation and see some other things that are possible to achieve in Terraform, but are not AWS specific. And Terraform provides perfect documentation for every single bit. And it also gives you the examples, yes? Like here, create 4. If I use count 4, it will simply create 4 similar EC2 instances. Can it be easier than that? Count 4. I don't need 4, I need 100, yeah? So what I'm saying in my code is count equals 100. That's all. 100 servers will be created. But if we go back to this count meta argument, you can also see something like that. Count.index. What's that about? Index is also like a programming language specific thing. Every item simply that will be created by Terraform will have its index number. And we can use that to have different names for each of those servers that are going to be created, because otherwise they will all have the same name. Maybe I will show you instead of trying to explain that. That will make sense then. So I will copy that count index, I will go back here, and I will call it my server not 1, because I have 100 servers, I don't want them all to be called my server 1. I will use maybe dash and then that count index, something like that. Or maybe even something like that. Oh, doesn't really matter. Let me just command S. Let's see what happens. Let me clear. We do Terraform apply. Before maybe we do, let's go back to instances and let's close all that crap. It's too many things. Now let me refresh that. Just wanted to say or show you that we have no instances running. I mean, we've got 3, but they are terminated now. We were playing in previous video with those. So if I choose instance state equals running, I should have none. Let's remove this filter. We've got 3 terminated. So let's go back to our code. Maybe I will make it slightly larger. Terraform apply and press enter. Let's see what happens. It says 103 to add. That sounds about right, because we have 100 instances, which means 100 virtual servers, plus VPC, plus 2 subnets. And if we check what's here, it's VPC, it's subnet 2, subnet 1, and then we've got our instances. And this is this index number I was talking about. For example, this one is 99. Just wanted to double check it's T2 micro. Yes, that's fine. If we go further up, we've got 98, etc. And somebody will say, why it's 99 and not 100? I don't think I can scroll up that far. No, I can't. But the thing is, this index number starts counting from 0 by default. So 0 is really server number 1. And 99 is server number 100. I mean, yeah, well, I could change it, like do add +1, but there is really no point, and it would start from 1 and finish on 100. That's not my point, really. We see that it's going to create 100 servers, so I just say yes, click enter, and they start being created. We see that it's random, like a number. It doesn't start from 0, 1, 2, 3. It simply tries to create them all at the same time, or in batches, like a bunch of servers first and bunch of server next. Maybe if we go, it's completed. As we can see, 13 seconds, so we should already have some. If I refresh quickly here, alright, we can see some of them already up and running, yeah? So let's go back to our code. We've got 68, creating, roughly 22 seconds. Between 13 and 22 seconds I can see the creation time for each server. Like here, 22 and 13. More and more of them created. So if I go back, 28 already. If I refresh, 37, refresh again. We've got more and more servers. Refresh again. Oh, 99 is being created. That's the last one. Alright, that wasn't successful, which is funny, because it says API error vCPU limit exceeded. You have requested more vCPU than your current vCPU limit of 32. I was not aware of that, to be honest. I didn't know that there is something like that. I used to be able to create 100 servers in the past. That wasn't a problem. It says now, contact Amazon EC2 request an adjustment to this limit. So it looks like we have some limit. So how many servers were actually created? Let's have a look. It stopped at 37. But you know what? That wasn't the point. We are not going to request some changes to the limits. My point was, it's simply very easy to use those count meta arguments or other meta arguments to create multiple things of the same type or of similar type. We've got 37 instances, so that's good enough for me. I don't really need that limit to be adjusted. So I just say Terraform destroy, auto approve. Press enter, and we will destroy what we have there. When you destroy, you will see that Terraform will destroy only, you can see now, 37 to destroy. Terraform knows how many of those servers were created, and it knows exactly how many it has to destroy, because it keeps all that information in tfstate file. And we can see they now have been destroyed, so if we go back and refresh, we shouldn't have any. I mean, they've been terminated. So again, instance state. If we check for instance state running, we shouldn't have any. And we don't have any. That's cool. So now you have some Terraform knowledge. The question is, what do you do about it? What do you do next? Yes? How do you learn even more about Terraform? And the fact is, Terraform documentation is really all you ever need. Because if you go back, I could go with you through every single example here, how to configure Athena, yes, in Terraform, etc. But what's the point? You've got here all the documentation you need, and you even have the examples ready for you. I can't see the point of doing this. And secondly, I don't even know if you want to work with AWS using Terraform. Because what if you, for example, want to use GCP, like a Google Cloud provider, So how do you use Terraform with GCP? Well, the answer is, you simply go to Google and you say Terraform resource GCP, Google Cloud provider, yes? And then instance, for example. What do they call their instances? Oh, it's Google Compute Instance. And you just click on that. And you have the examples here, how to use Terraform with Google services. And we've got Google Compute Instance, it's called default, you can change this name to whatever you want. The machine type is slightly different and to standard too, but that's very easy to figure out. You just have to check on Google Cloud what exactly it is and which instance type you need. You've got the zone, you've got the tags, everything's very similar to what we used to have in AWS. So basically, just refer to the documentation, go through it and play with it. And it's, as I previously mentioned, don't rely only on what's available for particular provider, just check the Terraform documentation to see what's available and what is not. Like we did with those count meta arguments, yes? Because this is basically the documentation for entire Terraform, and you can see the resources, but you can see meta arguments, you can see modules. Modules are like equivalents of functions in HashiCorp Configuration Language, where you create one module and you can reuse it, changing parameters and attributes. But I will not go through this, because this is not for the beginners, and you will only work with that when you work with huge infrastructure. Then you might want to use modules. But my point is, from here, you can go anywhere you want, work with anything you want. You just need to use this documentation, and it will tell you exactly how you use that particular resource or that particular function or utility within the Terraform. Also remember that if you don't want to stop here just on Terraform, you can learn many other DevOps tools if you just go to automationavenue.com platform. You will find AWS training, you will find Python programming training, and many more information. Like, if you want to progress towards DevOps or cloud engineer, that's a perfect place for you to start. So if you followed this material and you played actually with infrastructure in AWS, maybe you want to add maybe load balancer, maybe target group, etc. Maybe you want to add more and more elements to your infrastructure and play with that. But all of the information you need is in the Terraform documentation with examples that are ready for you. You just copy paste them and amend whatever you want to amend. So I hope that's helpful, and thank you for watching.